Good morning, friends. This is Dr. P. Munaswamy, Professor, Department of PCE. Today, we can see the another pulse modulation techniques, that is the pulse width modulation. It is also known as a pulse duration, pulse time modulation. So already in the last class, we have discussed about the different types of the pulse modulation techniques. So overall, we can classify the modulation into broadly two categories. One is the continuous wave modulation. This is the first one. So another one is the pulse modulation. So already in the AC modulation analog communication system, we have already discussed all the continuous wave modulations. That is the A modulation, that is amplitude modulation. Another one is angle modulation. So under the angle modulation, so there are two types are there again. One is the frequency modulation, another one is the phase modulation. So these are all the continuous wave modulation techniques. So why? Because the carrier signal used in this modulation technique is continuous wave, sinusoidal wave continuous, which is a continuous wave modulation. So that these all the modulation comes under the continuous wave modulation. So it may be amplitude modulation, it may be frequency modulation, or it may be phase modulations. Then coming to the pulse modulation techniques, where we are going to discuss under this pulse modulation only. So in the previous class, we have discussed about the one of the pulse modulation techniques, that is the pulse amplitude modulation. So under the again pulse modulation techniques, we are going to have the two types. One is the digital modulation. This is the digital modulation techniques. Another one is the analog modulation. So under the digital modulation, we are going to have it is a completely purely on the domain of the digital. So as an example for this modulation is pulse code modulation. So the advance for this one, we are going to have the delta and the adaptive delta modulation techniques are there. So need not worried about these modulation techniques. Now we are going to concentrate more on the analog modulation techniques. Analog modulation techniques. So under the analog modulation techniques, we are going to have the three types. One is the pulse amplitude modulation. Another one is the pulse width modulation, which we are going to discuss under this class. And third one is the pulse position modulation techniques. So here, what is the basic signals used in this pulse modulation techniques? So already in case of the analog modulation techniques, that is in case of the continuous wave, amplitude modulation, frequency modulation, phase modulation, the sinusoidal, which is the continuous, can be act as a carrier signal. Whereas coming to the pulse modulation technique, especially in case of the analog modulation, so the pulse, the train of pulses, a group of pulses can be act as a carrier signal for this case. So that is here the pulse carrier signal, the pulse train of pulses can be act as a carrier. Here continuous sinusoidal wave can be used as a carrier in case of the continuous wave modulation. So it is because the name itself indicates pulse modulation. The pulse group of the pulses, a train of pulses can be act as a carrier in case of the pulse modulation techniques. The name itself indicates pulse modulation means pulse carrier can be a train of pulses can be act as a carrier signal here. Then under in the last class, we have discussed about the pulse amplitude modulation techniques. Pulse amplitude modulation techniques. So here the pulse, the amplitude of the carrier signal is varying according to the strength or instantaneous value of the modulating signal. That is a pulse amplitude modulation. Here we are going to consider the similar to our continuous wave modulation. The carrier signal properties are we are going to consider the amplitude, frequency, and phase. So based on the variation of the parameter of these, you can have that type of modulation. So amplitude modulation, frequency modulation, phase modulation. And under this continuous pulse modulation technique, here also we are going to consider three parameters because there are three types of the modulation techniques are there. Pulse amplitude modulation, pulse width modulation, and pulse position modulation. So here the pulse amplitude modulation is the parameter amplitude. The amplitude of the pulse carrier is varying according to the instantaneous value of the modulating signal. Then it's called pulse amplitude modulation. Similarly, coming to the pulse width modulation, here also the width of the pulse or duration of the pulse, the total time taken by the on period of the pulse, is varying according to the instantaneous value of the modulating signal. That is called pulse width modulation, pulse duration modulation, or pulse time modulation. All the three names are same to the pulse width modulation only. So the width of the pulse is varying according to strength of the modulating signal. Then coming to the last one is the pulse position modulation. Here the position of the pulse. So take the pulse, one thing. So there are two edges are there. One is this is the leading edge. This one is called the trailing edge. So based on the position, we are going to consider the it may be leading edge position or it may be trailing edge. So this is called leading from higher to lower value. This is trailing edge from higher to lower value. So that we are going to consider any one of the edge. So based on the position of the edge, it may be leading edge or it may be falling edge. Is varying according to the instantaneous value of the modulating signal. So that is called the pulse position modulation. So here also we are going to consider the three basic parameters, that is amplitude, width and the position. So based on the variation of the concerned parameter, we are going to have the concerned modulation. So that is pulse amplitude modulation, pulse width modulation, pulse position modulation. Now today you can see the pulse width modulation or pulse position modulation. So here we are going to see so according to the analog modulation techniques, we are going to have the three types what we have discussed. That is pulse amplitude modulation, pulse duration, pulse width or pulse time. It is also known as pulse time. And third one is the pulse position modulation, PPM. So abbreviation for this pulse amplitude modulation, PAM. So pulse width modulation, PWM or PDM. Duration modulation, if it is considered as a duration modulation, it is a pulse duration modulation. Last one is pulse position modulation. So already discussed. These are comes under the digital modulation technique, PCM, pulse code modulation. The advanced of the pulse code modulation. Digital means the complete modulation will be processed in terms of the entries, that is zeros and ones only. So that is completely digital modulation techniques. So that is pulse code modulation. The advance of some of the advanced techniques for the PCM is known as a delta modulation. So now we can see the pulse width modulation, what you have discussed in the last class. Pulse amplitude modulation. So the first one is it is a continuous the signal which is to be carries the information, our modulating signal. So you take any modulation techniques. There are three types of signals you are going to consider. So one is the modulating signal, another one is the carrier signal, and third one is the modulated signal. So these are the three basic or fundamental signals which we are going to face for any modulation. It may be analog modulation or it may be digital modulation techniques. The primary purpose of the modulating signal, it is known as a message signal which carries information. The information is just to be traveled or carried by this modulating signal only. Thus, the main content, the main information is available in the modulating signal only. Then coming to, because if it is a pulse modulation techniques, a train of pulses, what you have discussed in the previous slide also. A train of pulses can be used as a carrier signal here. So because it is a pulse modulation techniques, we can use a train of pulses as a carrier because we have taken the pulse modulation techniques. Then according to the taken of the parameter consideration, carrier signal, pulse carrier signal consideration, the amplitude of the carrier signal is varying according to the instantaneous value of this. You take based on the instantaneous at zero level, instant of time. This is the peak value. This is another lower value. So based on the corresponding instant, the proportional variation in the amplitude of the carrier signal. So here we can see all the after modulation. This is the modulating signal. This is the carrier signal in terms of the pulses. Then this is the pulse amplitude modulated signal. You can see the joints or tops of all the modulated signal will realize reconstruct the original signal, modulating signal. So this is about the pulse amplitude modulation techniques. Now coming to today's our topic is similar to this is also in a pulse width modulation or it is also known as a pulse time modulation, pulse duration modulation. All the three names are same for the pulse width modulation. So the name itself indicates the width of the pulse or the duration of the pulse or pulse time, on time, pulse time of the carrier pulse is varying according to the instantaneous value of the modulating signal. That is known as a pulse width modulation or pulse duration modulation or pulse time modulation. Then coming to the, we can see the here. So there are three variations you can see here. Based on the variation of the modulating signal strength, the width of the pulse can be varies. So first one is the leading edge of the pulse is held constant and change the pulse width according to the modulating signal strength. So that means this is the carrier signal. This is our modulating signal. We are going to consider this leading edge and trailing edge. So we can vary the width of the pulse according to change of the position of the leading edge or trailing edge, or making the both are same, equal to on both sides. So that is the important here. So you can see the three diagrams here. This is the pulse. This is our modulating signal. So A correspond to leading edge of the pulse. So that means we are going to make the constant of leading edge as a constant and move the trailing edge according to the strength of the modulating signal. Similarly, sometimes you can make the trailing edge as a constant and move the leading edge as a movable element. So that means any one of the edge can be made as a constant. It may be leading edge. If you make the leading edge a constant, then automatically you can move the trailing edge according to the or modulating signal strength. Similarly, if you make the trailing edge a constant, I make the movement of the leading edge according to the strength of the modulating signal. Or make the both are a middle of the pulse will be constant. Pulse width on both sides. It may be leading edge and as well as the trailing edge can be moved on both sides. So according to that modulating signal strength. So here we are going to take the three cases. How we are going to, the aim is the width of the pulse can be varying according to the instantaneous value of the modulating signal. Am I correct? So that is the case here. So the change of the width of the pulse can be three ways. Here we are going to take. So one is the making of the leading edge a constant and moving the trailing edge. Another one is the making the trailing edge as a constant and moving the leading edge as a variable. Or third case is making the center of the pulse is a constant and make the movement on both sides, maybe leading edge side as well as the trailing edge side. So that is the three cases how we are going to vary the pulse width modulation. So here the generation technique. So there are simple technique for generation of the PWM. So here you can see the diagram. So there is a first one is the input signal, which is our modulating signal indicated by x of t, and sawtooth another signal. Sawtooth signal is given to the other side. So by comparing the both input signal and sawtooth, so there is output of the comparator will makes the pulse width modulation. So that is here we are going to take the based on the strength of the modulating signal or the value of the instantaneous value of the modulating signal. The sawtooth can be sliced. The waveforms can be which is given to the second input of the comparator, which can slice the, so according to strength of the modulating signal, then the output of the comparator will generate the PWM or PTM or PDM, pulse duration modulation, pulse width modulation or pulse position modulation. So that is the main purpose of the usage of the comparator, which is the op amp, to generate the PWM, pulse width modulation. So you can see the diagram here. It is a demodulation techniques. So by seeing this diagram, so the input signal for this one, what is the signal generated, is given to there is a zero order holding circuit is there and low pass filter demodulation of the PWM. So overall, you can see how we are going to generate the original signal. So receiver side, coming to the demodulation side, our aim is how to retrieve the original signal. So there is a input signal is given to PEPM, and that is given the switch is there. The switch operation, while I close it, it will be given to signal. And then there is a charging across the capacitor. So this charging discharging. So based on the opening and closing of the switch position, the capacitor, if it is closed, the capacitor will start the charging towards the peak value, and then open side, then automatically whatever the energy stored across the capacitor can be discharged as a output. So the finally we are going to get the this all the pulse width positions. The joining all the tops will be retrieving the original modulating signal. So once you have the voltage circuit output, then there is a arrangement of the low pass filter. The purpose of the low pass filter is which can allows the only low signals, the signals which are lying below audio frequency range. So our aim is finally retrieve the original signal of modulating, which is available in the audio frequency range 20 Hz to 20 kHz. So after getting the holding circuit output, that can be passed through the low pass filter, which allows the low frequency components, which are unwanted signals only. Is there any unwanted signal, that is high frequency components are there? So automatically that can be eliminated, rejected by the low pass filter, and allows the only wanted signals only. So final output we are going to get the our original modulating signal. So this is the time division multiplexing. You know that what is meant by time division. Overall multiplexing can be categorized into three types. One is the TDM, FDM and CDM. So time division multiplexing, and then frequency division multiplexing, and then code division multiplexing. So time division multiplexing nothing but here by the support of the multiplexing operation you can transmit a composite signal, and that can be decomposed at a receiver side. So that means the signals can be separated in time, is known as a time division multiplexing. The signals are separated in frequency, then it is known as a frequency division multiplexing. If you are assigning the separate codes for independent signals, that is called the code division multiplexing. So based on this multiplexing operation, we can transfer at a time more number of signals. So with the support of this operation, at a time we can transfer the more number of signals only. So there is that indicates we are providing the more facility to use the more number of customers or subscribers to use these communication techniques. So that is the main purpose of the time division, frequency division and code division multiplexing operations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.